All right, thanks, Tamara. Whew, it's hard to give the first talk after that awesome movie trailer. But we'll start to do some science. So what I like to do is to tell you briefly a study we designed to look at a natural form of memory retrieval in the MRI scanner. So as you all know that the cognitive neuroscience of memory goes a long history. And there have been probably thousands of studies that's been dedicated to look at the neuroanatomical basis of memory, in particular the episodic memory. And a lot of the studies are designed around the association between simple stimulus. And we typically use face and name association. So in those situations, the participant would be instructed to memorize a pair of between a face and a name. And then after a break, they would be then asked to retrieve this particular association. So studies use this type of association have taught us a lot about memory processing in the brain. In both healthy as well as clinical populations. And in general, the field agree that the medial temporal lobe, the hippocampal structure, as well as regions in the deformal network, such as precuneus, angular gyrus, are involved in memory processing. However, there are still a lot of debates in the detail how those different regions interact. And there's also a growing concern about the ecological validity about some of this kind of association studies. As you can see, the associations can be quite arbitrary, as well as the stimulus used in those studies do not have the dynamic and richness of the events that we experience in real life. And there has been some recent very innovative designs to address this ecological validity issue. Some of them would actually using GPS-embedded cameras to track real events in participant life and then tailor this back to play it in fMRI. However, these studies are still quite difficult to actually carry out. They require setup across multiple days. So in our study, we want to be able to design a study that we can control as much as variables as possible, but still using naturalistic stimulus. And we also want our paradigm to be short and sweet. We can slide them into a large multimodal imaging study in healthy as well as clinical population. So we took inspiration in a situation I'm sure most of you would experience, where you would be sitting at home, you'd be watching your favorite TV program, which could be a netball game in Australia, and then a commercial break would come on, and so you would be watching somebody eating a Big Mac patiently, and this commercial break would finish, and then your TV program would continue on. And at this point, you would very likely automatically and involuntarily retrieve the information you received prior to the commercial break, such as the number of the score of the game and which team has the balls, etc., to help you with the ongoing program. So we want to borrow this situation into the scanner, and what we did was we selected around 20 news clips, and we split them into half. So the participants were giving the first half of some of the movie clips, the news clips. And then when they come into the scanner, they would be either viewing the second half, a continued viewing of the previous viewed news clips, or they would be viewing a naive condition, which content has no association to their previous experience. So this essentially is a hybrid block design, where we are manipulating these two conditions between a continued viewing, there's a memory retrieval, versus naive. And just like a block design, it is highly efficient. The total task takes about 10 minutes. So we first just did the good old general linear model analysis, and we found that the continued viewing conditions significantly activate brain regions in the deformal network, such as the precuneus, angular gyrus, as well as hippocampus. And interestingly, the activation in the hippocampus is highly biased towards the anterior portion of the hippocampus. And then we ask, how does the anterior hippocampus actually interact with the deformal network regions? So we use the dynamic causal modeling to look at their network interaction. I don't have time to go into the technical details, but just want to say that the overall winning model really highlight these connections from the anterior hippocampus to the precuneus. This is a condition that is significantly enhanced or modulated by this memory task we designed. So then we ask, okay, what are the behavior relevance to some of these network connections? So going back to our task, we actually designed a recall task after the imaging session, where the participant were asked to answer questions about the news clips they view, and also that they were asked to rate how confident they feel about their answer. And then we correlate this hippocampal to precuneus connection. And quite intriguingly, this connectivity between these two regions is highly correlated with their confidence of their memory, but not so much the accuracy of their memory. So suggesting that there is really some high-level metacognitive process going on that is benefited from this hippocampal to precuneus connection. So just a quick summary. What I present here is a study that we use news clips to engage a natural form of involuntary memory retrieval in the fMRI study. And we found that this memory retrieval process highly activates the anterior hippocampus as well as keynotes in the default network. And this information flow, it seems to be predominantly going from the hippocampus to the precuneus. And importantly, this connectivity, this information flow seems to be crucial to how confident we feel about our memory. We feel about the content of the news clips that we actually memorize. But of course, so here is this connection. But of course, no matter how confident you feel about your memory, this still could all just be fake news. So in the end, I just want to acknowledge Yudan Ren. She's a talented visiting student from China, and she has carried out most of the studies, most of the analysis. And she is also presenting a poster here at HBM. So if you have questions about the technical details about the task design, please feel free to go and talk to her. And I also like to acknowledge colleagues at QIMR who had contributed to the task design analysis, including Professor Michael Brixbier. And also thanks to Ziwon or Simon Eckhoff, who have really, we had a lot of conversation over emails about the task design as well as the stimuli selection. So thank you very much. So after me, please clap.